Hello everybody. What I'm going to show you now is another example of our double displacement reactions and predicting the solids. So let's say we've got something like PbNO3 4 plus CaI2. Okay, so again we figure out what's going to join with what. We'll get the Pb joining with the I, and notice I'm only taking one of each here, guys, just one of each. And over here we have calcium will join with the nitrate, and again I just take one of these, just one of these, that's all I'm taking. So now I figure out the charges on everything. So lead nitrate, Pb and the NO3s, we've got 4 of those. Got to figure out the charge on the lead here, negative, 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 negative. Oh, there we go, it's a 4 plus is what we have. So I'm going to put plus 4 up here. The I is a 1 negative, calcium is a 2 plus, and NO3 is 1 minus. And again, I can't stress this enough, folks. We take one of each of these across to the other side, and that's it. Okay, so rewriting the problem, PbNO3 4 plus CaI2, PbI4 plus CaNO3 Again, if you don't know what I just did, go back to Module 8 and you'll be able to figure it out. Now I know what you're saying. You're saying, well, there isn't 4 iodines here. It doesn't matter. We're just trying to figure out the compound that we're getting when we join these two together. We're going to balance everything out right now. Okay, so let's see. We've got 2 nitrates over here, but we've got 4 over here. So I'm going to put a 2 in front of the calcium. I'll put a 2 in front of this calcium here, and what do you know, everything looks like it's balanced. We've got 4 iodines here, we've got 1 lead here, everything looks like it's cool. Okay, so now we've got to figure out which one of these suckers is the solid. So we know that these are all aqueous, aqueous. Now we've got to figure out which of these is the solid. So we go back to our friendly solubility chart, and we look at it and say, okay, calcium and nitrate. Calcium and nitrate, where's the nitrate? There we go. And that's going to be aqueous, so that's no good. That's not going to be a solid. The next one is lead and iodine. We get lead and iodide, and what do you know? That's going to be I insoluble, so that one is the solid. Alright, so I will put an S on this one down here, and the rest of them are going to be AQs. Okay, so that's part A done. Now we're going to figure out how this splits up into ions. So we look at this and we see we've got Pb, we've got one of those in there, so that's going to split into 1 Pb4 plus, and remember I get a charge from up here. I see I've got 4 nitrates here, so I'll get 4 NO3 minuses, so that's how it's going to split up. Now over here I've got 2 calciums, that's 2 Ca2 plus, and we've got 4 I's here, plus 4 I minus. There we go. And again, we get the 2 plus from here, and we get the I minus from here. Alright, so everything is going out fine so far. We've got Pb I4, it's a solid. Remember, solids don't split up into ions, so we leave that the way it is. And the other one here is the calcium, which calcium nitrate will split up into 2 Ca2 plus 4 NO3 minus. So that's how everything breaks up into ions. PbNO3 4, I'll just do this real quick just so you can see. Negative, 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 negative. It's a charge of 4 plus on there. So when this splits up, it splits into 1 Pb4 plus and 1, 2, 3, 4 nitrates. And that's how we do it. And we can do it for all of those. The only one we don't split up is the solid which stays the way it is. The last part now is your net ionic equation. And again, what we do is we cancel stuff that's exactly the same on both sides. And you can see that's going to be the 4 nitrates and the 2 calciums. And what we're left with is Pb4 plus 4i minus gives PbI4 solid. And there's the reaction that forms the solid, and there is our net ionic equation. So there you go.